Okay, so we're going to answer this question before us. Make sure you answer A, B, and C before answering this one. So it says, one bowl is chosen at random. From it, two pieces of fruit are chosen at random. The first piece of fruit being replaced. We've got replacement here. Before the second is chosen. If both pieces are apples, find the probability that bowl A was chosen. So just as we saw in part C, this is also a conditional probability question in which we know that, it's given that two apples. So that's what we know. And we're trying to figure out the probability of A. So that means we're going the probability of A intersection two apples over the probability of two apples. That's what we're doing, people. We can think of our tree diagram here. So we've got either bowl A or bowl B. There's a 50-50 chance of getting either one. We only care about the apples. So let's just put the apples in. We don't care about the oranges. It's important to remember that replacement is occurring here. So for our first one, we have 3 on 8. And then for our next one, we have 3 on 8. And then for this one, it is 7 on 8. And then because it's replacement, it's 7 on 8 again. So because we're putting it back in, it all stays the same. And then the next thing I needed to do is figure out, well, what's the probability of A intersection of two apples? And that's simply found by multiplying across this way. That will give me that, which I know I need for that. Okay, so that means I'm going to end up with a half times 3 on 8 times 3 on 8. Now, unfortunately, you can't simplify anything here, so you're just going to end up with 1 times 3 times 3 is 9. 2 times 8 times 8 is 8 times 8 is 64, times 2 is 128. So that means for our first one here, we've got 9 on 1, 2, 8. And then we also need to figure out the probability of B intersection of two apples. So that's going to be a half times 7 on 8 times 7 on 8, which is going to be 49 on 1, 2, 8. And now the reason why I figured this one out, so remember the reason how I got this was just multiplying across that way. And the reason why I got them both is because now to figure out what the probability of two apples is, I need to add both of these up. So to figure out the probability of two apples, I need to go 9 on 1, 2, 8 plus 49 on 1, 2, 8. Which will be 58 on 1, 2, 8. 58 on 1, 2, 8. Okay, and then once we've done that, now it's just a matter of stay, change, flip. And would you look at that? That simplifies nicely. Which means my final answer here will be 9 on 58. That's it. That is my final answer. Hopefully you found that helpful. And yeah, I'll see you in the next one.